In this video, we're going to look at multiple examples of graphing using function transformation techniques. In each example, we're going to start with a known function, in this case, absolute value of x, and we're going to modify the formula and then look at what happens graphically. All right, we're going to obtain the graph of the final equation with a sequence of steps using function transformations. In each example, I'm going to have the equation listed and below it the overall format or shape of that equation involving parameters, and then down below we're going to graph it by adjusting the parameter to the appropriate numerical value per the example. So in this example we're starting with the absolute value function. Inside of there we're adding 3 to x. Inside of the absolute value we know that that shifts the graph left 3 units, right? For inside changes we do the opposite of what's indicated. Subtracting 6 on the outside, that's more direct. We're going to move the graph down 6 units by subtracting 6 from each y coordinate. Okay, so now going to the graph here, when we vary the parameter c from 0 to 3, that shifts the graph left 3 units. Now as we vary the parameter d from 0 to 6, that's going to move each point on the graph down 6 units. And this is the final product. Alright, so notice the domain of this function is all real numbers. It goes to the left and to the right forever, keeps extending, but the range in this case would be from -6 up to infinity. Okay, similarly for this example, again, we notice we've got the starting point function, the format below it in terms of the parameters a, c, and d in this example. Our starting point function is going to be y equals x squared. So we notice we have a squaring operation happening. Inside of there we have x minus 2. That's going to shift the graph right 2 units. Multiplying by 2 on the outside has the effect of vertically stretching the graph by a factor of 2. Subtracting 5 will move the graph down 5 units. Okay, so we're going to start on the inside first and work our way out. As c varies from 0 to 2, the graph is moved right 2 units. As a changes from 1 to 2, we see that the graph is becoming vertically stretched, it's becoming narrower. The graph is being pulled away from the x-axis, away from the x-axis, except the point where we're on the x-axis, where the y value is 0. When you multiply that by 2, you still obtain 0. And then lastly, when we shift from d from 0 to 5, that's going to move each point on that graph down 5 units. And there's the final product. Again, we could say that the domain is all real numbers. The range for this graph is going to be from -5 to infinity. All numbers greater than or equal to -5. Okay, for our next example, we see we have a square root in our equation. All right, inside the square root, we have x minus 5. That's going to move the square root graph right 5 units. Multiplying on the outside by 3 is going to vertically stretch the graph by a factor of 3. Adding 7 is going to move the graph up 7. Okay, so let's see what happens as we vary the parameters. Again, starting on the inside, we're going to move the graph right 5 units. Multiplying a, or varying a from 1 to 3 has the effect of vertically stretching the graph. So all the points are going to be pulled away from the x-axis unless you're on the x-axis. So in particular at the point 5, 0, that point staying fixed, the rest of them are being stretched and pulled away. And then lastly, as d is changing from 0 to 7, our graph is just moving up 7 units. So in this case, the domain of this graph is from -5 or +5 to infinity. The range, the lowest y value is C7. There is no highest y value, so the range would be from 7 to infinity. All right, in this next example, we've got 3 different things happening. This -2 on the outside, all right, that's going to be 2 vertical effects. One, stretching the graph by a factor of 2. Separately, reflection over the x-axis. And then lastly, we're going to move up 1 unit. So the way I've indicated that here is by S for sign, positive or negative, and then A is the parameter playing the role of 2, D is the parameter playing the role of 1. So we're starting out with our basic graph of the square root of x. We're going to first vary a from 0 to 2. Again, that's going to vertically stretch the graph by a factor of 2. Then changing S from +1 to -1, that's going to reflect the graph over the x-axis. And lastly, we're going to add 1 by varying D from 0 to 1. That's just going to shift the graph up by 1 unit. And that's the final product. Okay, in the next example, we've got an inside change. We're multiplying the input by 2. Remember, inside changes, we have to do the opposite of what we think. So instead of stretching by a factor of 2, we're going to compress by a factor of 2. Each x-coordinate is going to be cut in half. And then secondly, we're going to shift the graph down 3 units. So if we vary b between between 1 and 2, we see the graph is compressed horizontally. All of the points are moved closer to the y-axis. Okay, closer to by a factor of 1/2. So for instance, starting out at the point 2, 2, that point is going to be moved over to the point 1, 2. At the point 4, 4, that's going to be moved over to the point 2, 4. Okay, notice the range has not changed though. The lowest y value of the graph is still 0. There is no highest y value in our graph. Now lastly, we're going to move this down 3 units. Just shift the entire graph down 3. Okay, and finally, this is our last example. We've got multiple transformations happening here. Our parent graph is y equals x squared. We see squaring in our equation. Inside of the squaring, we're adding 2. That's going to shift our graph left 2 units. Multiplying by -3 again has 2 effects. Stretching by 3 vertically, reflecting over the x-axis. Lastly, adding 4 is going to move the graph up 4 units. So starting on the inside and working our way out. The +2, we move our graph left 2 units. Next, we're going to vertically stretch by a factor of 3. That's going to pull all of the points on the graph away from the x-axis. The graph's going to get a little bit narrower in this case. Then we want to reflect over the x-axis. So flip the entire graph below. And then finally, we're going to move the graph up 4 units. And there's our final product graph. Okay, notice in this case, the range has changed quite dramatically. Our original range was from 0 to infinity. Now it's going to be from -infinity up to 4. Alright, the range would be y less than or equal to 4 for this example.